welcome to another episode of SCFG Live, Science Club for Girls Live. I'm Hannah with Science Club for Girls, and that was Mr. Music with your theme song. Very nice, Mr. Music. What did you think of our intense countdown today? It's pretty cool, huh? Very intense. Makes you really excited for the show. Well, I'm so excited to be here, and I'm also excited to have one of my really good science sidekicks and friends, Namisha, joining us. Let's bring her in.
Hi, Hannah. And hi, everyone. I'm looking forward to another week of science. Last week was super fun. We learned about density, and we even got to use some fun candy, which was so much fun. Lori and Ashley from EMD Serono taught us such cool things about density with our candy. And today, I'm looking forward to...
Hey, scientists!
Wait. Dr. Marbles, how did you get in here?
Oh, what do you mean?
Like, I don't understand how you got here right now.
Oh, just a second. I was over here.
Yeah?
And I walked in.
Oh.
And I just couldn't wait any longer because I missed you both. And I just didn't want to wait. So what did I miss? What did I miss on the last episode?
It's a great question. Next time, could you knock Dr. Marbles maybe just to let us know you're coming?
Oh, I see. So I'm still on a must knock kind of basis. I get it.
Yeah, not until season 5 can you just bust in, but until season 5, give a little knock, okay?
Yeah, sure. No worries.
All right. Anyway, as Namisha was saying, last week we made a beautiful rainbow out of candy, and we discovered that honey was actually more dense than water, meaning its molecules are packed closer together than the molecules in water, which are farther apart.
And we also learned that everything has density, even our bones. Having solid, dense bones means they're strong and healthy, which is why it's so important to eat calcium-rich foods, like milk and cheese. Then we made predictions about which melted candy cup would be the most and least dense. And we made a rainbow.
That cup with the most amount of Skittles in it was the most dense, and it was basically at the bottom of the cup. And the cup with the fewest amount of those rainbow candies was at the top layer because it was the least dense.
Oh my gosh. That is so cool, Hannah and Namisha. That is so cool. Wow, I missed a lot.
You did.
Well, what a beautiful rainbow to celebrate spring showers.
Very true. And Dr. Marbles, I'm glad that you're back today because today we're actually going to continue learning about chemistry. So you won't feel too left out because we're going to continue the chemistry experiments today. And specifically, we're going to look at the chemistry of dry erase markers. Have you ever used a dry erase marker before, Dr. Marbles?
Yeah, I think so.
In fact, everyone at home might know these dry erase markers because oftentimes teachers at school use them to write on some dry erase boards and erase them right off. Like, take a look at this. Like magic, they erase.
That is so cool. Hannah?
Yeah.
Can you do me a favor? Can you do that again? But draw moi.
Oh gosh. Okay. Well, I'm not the best artist, but I'll try, Dr. Marbles. Okay, so
hold on.
Yeah, pose. How would you like to be drawn? Like that?
Hold on. Ready? Okay, ready?
Okay.
Go ahead.
Oh, okay.
All right.
Don't move. Don't move.
I'm not moving.
You're moving, Dr. Marbles.
I'm trying
not. Make sure he doesn't move, please. Okay, so your head is it's quite an oval head. Like that. Looks a little bit like a potato. And then your glasses are definitely rectangles. Okay.
Dr. Marbles, don't move.
I'm trying not
to. Moving. Dr. Marbles, I really can't focus if you're moving.
I'm trying not to. I'm trying not to even talk.
Yeah, don't talk. Okay, and then you're moving.
Hannah,
Yeah.
Who are you drawing?
This is you.
That doesn't look like me. Hold on a second. Try one more time. I'm going to stay really still. Go ahead.
Okay.
Go ahead.
Oh, I see now. Okay, so you do have some ears, actually, and
ears. Hannah, that's not the problem with that picture. The ears are the least of the problem with that picture.
What's wrong? What's wrong with this photo?
Yeah, there were square glasses.
Oh yeah, I guess they're a little bit more round.
Yeah,
No.
but that's the beauty of it. You can erase it.
Exactly. And it's super easy to erase dry erase markers. Just a little wipe with a paper towel, and we could start over, but we have too much to do, Dr. Marbles, so we're going to have to move on.
Well, thanks for trying.
You're welcome.
You did get the oval right.
I know. I did get the oval right. But what's super cool about these markers is they can erase because of the ingredients that are inside these markers, and that's exactly what we're going to find out today.
Yeah, exactly. You can wipe away dry erase markers because of a special solvent. A solvent is a part of a solution. We learned about solutions a few weeks ago, remember?
Yep. I totally remember that, Namisha. We learned about mixtures and solutions with our friend Rita. She told us that a solution is a kind of mixture where one material dissolves in another, making it kind of difficult to separate from its original ingredients. It's like the salt water. Remember when my dentist told me I had to use salt water and I couldn't get the salt out of the water? Remember that?
You're exactly right, Dr. Marbles. Good example. And we made our own solutions by dissolving that sugary drink mix into water until you couldn't see the powder anymore. The solvent of that solution would be the water. A solvent dissolves the other substance in the solution.
I totally am getting it now, Namisha. So the solvent in my saltwater mouthwash was also the water.
That's exactly it, Dr. Marbles. Nice connection. Now, in dry erase markers, the color pigments that make up the color actually are able to dissolve in the solvent. And in addition to a solvent, dry erase markers have something called a polymer. And a polymer is something really cool, and this is exactly what makes dry erase markers erasable. It's also a fun word too. And a polymer is made up of a couple of different molecules that are bonded together. In fact, it kind of looks something like a chain of paper clips, a bunch of molecules that are bonded all together like this. And in dry erase markers, the polymer is really slippery. It doesn't like to stick to surfaces like the whiteboard, which is why dry erase markers are really easy to erase.
Oh. Permanent markers also have this type of polymer in them. But instead of being slippery, this polymer sticks to other materials, which is why you can't easily wipe off drawings with permanent markers. So this is why we really have to be careful and really shouldn't use permanent markers around whiteboards.
Totally. You got to really be careful, actually. Is that what makes the dry erase and the permanent markers different? Just that type of polymer? That is a fun word. It's amazing just how the difference in chemical properties, just a simple difference, can make a big difference in the everyday item. It also makes me think how important stain removers are.
That's very true. And that's
right, Anna? Right,
yeah.
Anna?
What?
I mean, aren't stain removers really important to you?
Yeah, they are. I tend to spill a lot.
Just a little.
They're quite important. And honestly, that's just the power of chemistry, this difference in polymer. And today we're actually going to play around with the chemistry of these two markers and have some fun drawing. So Namisha, what do we need for this experiment?
Well, we're going to need 2 shallow plates or bowls or trays. Got that, Hannah?
I do. I have these ones. Will these work?
Perfect.
Cool.
All right. And even though we'll be able to erase our drawings at the end of our experiment, let's just make sure we get permission to write on the surfaces first. It's always good to ask permission, right, Hannah?
Yep, perfect. I've already asked Mr. Music, and he says I have permission to write on these. So
awesome. Thanks, Mr. Music. We'll also need some dry erase markers, 1 permanent marker, a cup, and some water in it. And then later we'll need some rubbing alcohol. And how about, since we're using some water, let's have a couple of paper towels around.
That's a great idea, Namisha, especially because this can get kind of messy because we're using water, as you said. Okay, so I have my markers and I have my things, and I also have let my water sit out at room temperature for a little bit because I think that'll make this experiment go a little bit easier. Okay, what's next?
Well, Hannah, Chem You Draw?
I get it. Wait, can I? Because chemistry. You're funny, Namisha. Very, very funny. I'm sure Dr. Marbles would have appreciated that joke.
Good. Yeah. Using different colors of dry erase markers on the plate. Now, how about we draw some beautiful drawings? How about we draw 2 different shapes? We're going to draw a circle. So let's take a dry erase marker.
Does it matter what color? We can use any color?
We can use any color.
Cool.
And let's draw a circle.
Okay.
And let's color that circle in.
Oh, this is kind of fun.
Yeah.
Drawing on a plate.
I know. When could we ever do this other than science?
No. Okay, I have my circle and it's colored in pink.
Awesome. Okay. Now let's take another color of dry erase marker. And then we draw a triangle, but don't color this triangle in.
Okay.
All right.
Okay, I have my circle and my triangle.
All right, awesome. And remember, you all at home can draw whatever shape that you want. And let us know in the chat which shape that you're using.
Cool. Well, here's my beautiful drawing. And it seems like Dr. Marbles is a drawing expert because he critiqued my drawing of him so much. So let's bring him in and see what he thinks of this one.
Hey, guys. Hey.
Yeah?
I'm making sure no one's around.
Why?
Because you're both drawing on plates.
Oh, that's a good idea. But I told Namisha I got Dr. Music, Mr. Music's permission, and he said I can draw on this plate.
Shh. All right, the coast is clear.
Okay.
What are you both doing? Drawing on plates.
I know. It seems insane, but don't worry. With the power of chemistry, we're actually going to be able to remove these drawings.
Well, they look stuck to me.
They are right now, but let's see what happens. Namisha, you want to show us?
All right. Well, how about we rub our finger across our drawings and let's try to erase it.
All right, I'll keep a lookout.
Okay.
Does that work?
Huh. That looks like they're erasing, Namisha. That must be, are those the erase markers?
Hannah, are they the erase markers?
They are the erase markers. They are the dry erase markers, and they're not sticking. They're easily wiping away and erasing.
Why didn't you both tell me? Oh,
Sorry.
I'm so worried.
Yeah. I think this is super cool, but what do we think is going to happen? I feel like it's time for...
Prediction chicken! Oh, I missed that guy.
Dr. Marbles, we're about to pour some water onto our drawings, onto our plate. What do you think is going to happen?
Well, I think the dry eraser, well, it wiped away so easily because of that special slippery polymer. I love saying that. So I think the water's going to wash it away. I think the water's the solvent. I think
That's a great prediction. That's a great prediction, Dr. Marbles, and I think you might be right. I finished coloring my drawing, even though I erased a little bit of it, just for our test.
Okay.
All right, Namisha, what's up?
All right. Let's see. How about we pour a little bit of the water onto the plate, okay? Just enough to cover the drawing, though.
Good luck.
Here we go.
Solvent doing its thing.
Whoa!
Wow.
Namisha, my drawing is like coming off of the plate.
It's like they're floating.
Oh my gosh. In fact, you're right, Dr. Marbles. My drawing looks like it's kind of floating in the air right now, or in the water right now. And if I try and pick it up, slimy and yuck.
That is so cool.
Oh, maybe it's the polymer that you were talking about, Dr. Marbles, that's making my drawing all slimy and floating in the water.
Maybe. How about we do the same test with our permanent markers to see what happens with the permanent markers?
Be careful, guys. Be careful.
I know, Dr. Marbles. We'll have to see.
Okay, let's see. Dr. Marbles, we'll call you back in a second.
I'll be right here.
All right.
All right. Do we have our second plate?
Yep, I got my second plate right here. It's the same exact kind of plate, just clean and nice.
Okay. All right, let's grab our permanent marker.
Okay.
Okay, and let's draw our shapes again. You can draw any shape you want. How about we draw a heart?
Cool. I already drew a triangle.
Awesome.
Is that okay if I drew a triangle, Namisha?
Yeah, of course. It's okay.
I'll color it in again, too.
All right.
All right.
All right. So now, what if you wipe your finger across your drawing and try to erase it like we did last time?
It's erasing a little bit, but definitely not as much as the dry erase marker. What about yours, Namisha?
Yeah, it's pretty permanent, I'd say. And I feel like that makes sense because we talked earlier about that polymer in permanent markers. And because of that polymer, the permanent marker binds to these surfaces. But what if we add water now to this plate? You think it's going to wash away or float like the dry erase markers? I mean, dry erase drawings. Yeah.
I don't know. I think it might be time for prediction chicken number 2. Dr. Marvel.
Oh, yeah. What was the question? Sorry.
Well, we have not. Did you want to do the intro for the prediction chicken? Because that's kind of fun. Do you want to do?
Actually, would you mind?
Yeah, that's fine. Ready?
Okay. Yeah, we'll be ready.
Okay. I think it's time for.
Oh, I didn't think you'd come so fast. Let's try one more time.
All right. I think it's time for
prediction chicken! Prediction chicken! Hey, we get to do 2 prediction chickens. What's the chances for that?
Finally. Now, Dr. Marbles, the question is, we've done the same kind of drawing on the plate thing, but this time we did it with permanent markers. And so we're wondering if we pour water on these permanent marker drawings, what's going to happen? Now, Gianna thinks it's not going to float like the erasable markers did. What do you think?
I think Gianna might be right. Like you said, Namisha, the binding polymer will, my sense is it's going to probably stick to the plate. But water can be powerful. Let's check it out. Let's see.
All right, let's see.
Pour the water.
Okay, I'm going to pour a teeny bit of water on our plate, just like we did with the dry erase markers.
Okay.
Remember, this is with the permanent marker now. Well, it doesn't seem like anything's happening. Like it's still stuck to the plate. I can't pick up the drawing like I could with the dry erase marker. This is not as fun, I will say.
And right, scientist, Dr. Marbles had nothing to do with putting that marker on the plate, right? That was not my idea.
But if scientists, if anyone asks whose idea it was, we will say Dr. Marbles.
Well, let's just say I was observing, but I had nothing to do with putting that marker on the plate.
We'll see about that. Well, okay, so what is happening here, though? Let's talk about the science behind this. So it seems like dry erase markers, they were able to come off the plate with just water and float, but the permanent markers are still kind of stuck to the plate. So it seems like maybe something about the chemical makeup of these markers is creating different outcomes when we add the water.
Yeah, exactly. Only the dry erase markers were floating to the top. And then the permanent marker was sticking to the plate no matter what.
Hey, Hannah and Namisha, I have a guess. I think I know what happened.
Well, tell us.
The polymer. That's what we keep talking about. And you said that the only difference is the polymer between the 2 markers. I think that's what made the difference.
You're exactly right, Dr. Marbles. And way to listen this episode. You've done a really great job of listening for that keyword polymer.
And sitting on the screen.
Because of the polymer. That's exactly it. The polymer in the dry erase marker is slippery. It doesn't like to stick to the plate. And that's why when we just added the water, it floated right up because it allowed the water to kind of seep under it. But the polymer in the permanent marker does like to stick to surfaces. And that's why it's not floating when we added the water.
Yeah.
Exactly. And because the ink is lighter than the water, it floats.
Totally. Namisha, it's lighter than it. Hey, this reminds me of when we learned about density, right? right? Scientist, density isn't that the amount of mass that something has?
That's exactly right.
Huh.
That's a really good connection, Dr. Marbles. And when the molecules are spaced closely together, it has a high density and it's heavier. And then when the molecules are spread apart, it has a lower density and it's lighter.
I got this. Watch this. So that means that the molecules in the marker are closer together than the molecules in the water.
That's exactly right, Dr. Marbles. Great connection. Awesome work. And super cool. We've been able to connect different episodes together because it's true. Science is kind of all related. So awesome work. And I think a cool extension activity that everyone could do at home is maybe try different colored dry erase markers and see if one color does a better job at floating than another. Because that might tell you about, do different colored markers have different densities, even if they're both dry erase markers? It'd be really cool.
That would be super cool, and we would love to hear all about it. I think this has been such a great show, and I can't wait for next week.
Wait a minute. Wait.
Yeah.
Don't stop the show yet. Are you stopping the show?
Yeah. Well, yeah. It's time to end.
Please wait. We've got a serious problem here. I've got 5 plates. I've got some guests coming over, socially distanced, of course.
Good.
And I'm supposed to be serving them Dr. Marble's famous fish sticks, and I've got marker all over my plates. What am I supposed to do?
Well, Dr. Marbles, I'm really glad that you told us about this super serious
mess.
Dr. Marbles. Okay, first, just take a deep breath. Take a deep breath.
Hold on to the fish sticks, chicken.
Just take a deep breath. Okay. All right. So I'm glad.
It's very hard to ask a chicken to hold on to fish sticks.
Because they don't really have hands.
They don't.
Okay, but Dr. Marbles, here's the thing, is that we can actually help you solve this problem with a solvent that we talked about at the very beginning. And a solvent will actually help to dissolve that permanent ink that's on your plate.
Oh, I have an idea, Dr. Marbles and Hannah. How about we use rubbing alcohol for our solvent?
Okay.
But let's make sure an adult's around because we always want to be careful and safe when we use all these fun chemicals, right?
Okay.
That's a great idea. Okay, so Dr. Marbles, all you need to do is just put a teeny little bit of rubbing alcohol on a paper towel.
Okay.
It's kind of like if you have nail polish on your nails and you use nail polish remover to get it off. It's very similar. Okay, now all you need to do is take your rubbing alcohol on your paper towel and just rub it on the plate.
Rubbing it on the plate.
And voila, your permanent marker is gone.
Oh.
The solvent, rubbing alcohol, dissolved the ink of the permanent marker, and now you're ready for your fish stick dinner.
Kablam! All fixed? Wow. You had me worried for a second, scientist, but clean as a whistle.
It's very
Bring over the fish sticks, chicken. Oh, that's great. Thank you. Thank you for letting science fix the problem, as always.
Of course. And it's so cool that chemistry's all around us, isn't it, Dr. Marbles?
Oh, my gosh. It's super helpful.
Yeah. Even from that yummy trail mix that we ate to all these fun markers and chemicals that we're using.
You can't get away from it.
I know. And that's what I love so much about science. The more you experiment, the more we find out such cool things about our world.
Very, very true. Oh, Gianna had a very good point here, which is that we should definitely wash our plates before we use them because you don't want your fish sticks to taste like rubbing alcohol, Dr. Marbles.
No. And you know what else? You know what else I was thinking, scientists?
Yeah.
This lesson taught me something. It was the relationship between the solvent and the polymer. It felt like the relationship mattered. And it made me think about how some relationships are really strong and some relationships float away. So I thought that was really interesting. So thanks for including me, scientists. Loved it as always.
Dr. Marbles, you need to write a book about something because you have some very deep connections that I would have never made.
Hannah.
Yeah.
I'm working on it. Problem is I did the first draft in erase marker. Just kidding.
Dr. Marbles, you have to add some prediction chickens in your book too.
Oh yeah, he keeps reminding me.
Yeah. Yeah, he's a key character. Well, I'm really excited for next week's episode too, because we're talking about more chemistry, because there is so much to learn. And before we close out, I do have a very exciting announcement for all the adults out there that are watching, because we'd like to invite you to the 2021 Virtual Catalyst Awards. This is an awesome opportunity where we get to show you all the cool things that are happening at Science Club for Girls. And in fact, Dr. Marbles, there's a rumor going around that you might be appearing as well.
Do you think?
I don't know. You'll have to
can't wait.
Out. Well, check out our website for more details, because we'd love to see everyone there. And until next time, it's been a fantastic episode, and we hope to see you again on SCFGI.